Anybody have an issue with the problems on sheet 2? That was an old quiz, I believe. Anybody have a question about that? Maggie? Okay, no, wait. I am on sheet 2. There's only 4 problems. So we'll get to whatever you're talking about, but right now I'm on sheet 2. Anybody on sheet 2? There's 4 problems. It was a quiz. Anybody have a question? Delaney. I'm going to leave my formulas here because I'm probably going to need them. It says the 6th term of a geometric sequence is 160. The first term is 5. Find the ratio. It's a geometric sequence, kids. Geometric sequence. Which formula up there has to do with geometric sequences?
Second one.
Number 2. So it says the 6th term will equal the first term times the ratio to what power? The 5th. Why the 5th? Because this is a sub 6. So n is 6, meaning n minus 1 is 5. So how do I solve this equation?
5 by 5.
So 32 equals r to the 5th, and now I'll take the 5th root of both sides? So the ratio is 2. Was that the question? Yep, find the ratio. Maren? 2009, is that a term of -3159? Okay, so what kind of sequence is this? Arithmetic, right? The question is, if we keep going far enough, will 2009 actually be a term in the sequence? That's the question. Okay? Now, which formula is going to be appropriate here?
Let's say yes.
The first one. The first one. If you are looking at any of these, you're completely off target. Because what do these do? They add. Does this problem have anything to do with addition?
Nope.
No. So you're narrowing it down. It's got to be one of these. You've already determined that this is arithmetic, right? So it's got to be the top one. You want to know, does 2009 happen if you take the first term plus the common difference times n minus 1? Will you get 2009 if you apply that top formula up there? All right. Add 3. Divide by 4. What's 2012 divided by 4? I should be able to do it. 503. So n equals 504. Tell me the answer to the question.
Yes.
Yes. Which term is it?
504.
The 504. Can somebody tell me what would happen if it weren't a term?
It wouldn't be a whole number.
It wouldn't be a whole number.
Boom.
We could put anything here, kids. We could put anything here and be able to solve that equation. Would you agree with me? We can solve that equation. But if this is a term, then the answer has to turn out to be a whole number. Because you can't have the 12.3 term, right? It has to be the 12th term or the 13th term or the 504th term. So that does work. The answer is yes. It's the 504th term. All right, you also had to do the back side of that. Any questions about the back side? Any issues there? Jessica? All right, number 4 says Jenny chewed gum twice on the first day, 6 times on the second day, 8 times. On what day will Jenny chew 1458 pieces of gum? This is sort of like the one we just did. The difference is, what kind of sequence do we have? This is geometric, so we're going to be using this formula. And we want to know 1458 happens, how many on the, twice on the first day, the ratio is 3 to the n minus 1. We want to solve this equation for n. We want to know which term of the sequence is 1458. So we'll divide by 2. Now 729 is not a number you probably use like a lot, but it is a power of 3. 729 is 9 times 81. And this is 3 squared, and this is 3 to the 4th. So 729 is 3 to the 6th. Now, if you don't recognize that 729 is a power of 3, you would solve this by taking the logarithm of both sides. Now, it's not necessary because we have this, we can get a common base. But if you didn't recognize that, you'd have to use logarithms to solve it. So 6 equals n minus 1, and n equals 7. So what's the answer to the question? She chews that much gum on the 7th day. All right. Anything else on the fun problems for practice sheet? Okay, let's look at page, oh wait, Delaney, which one were you talking about?
4.
Page 4?
Oh,
Oh.
mine is on page 1.
All right, let's look at page 1. There's a question on page 1. Which number? Yeah, if you put infinity up there, that's the same thing as not having anything up there. Is that a negative one?
Yeah.
So we kind of talked about this yesterday. This is page 1. This is page 1, number 10. And it's a sigma that needs evaluated. What does sigma mean? We talked about this yesterday. Sum. So we're going to add, right? Now, all of these formulas add. This is kind of a dead giveaway.
Geometry.
It's got to be right here. This is the only one that deals with infinite things. So that's the formula we're going to use. However, in order to use that formula, what do you need to know? The first term and the ratio. So let's write out a few terms and see what we get here so we can figure out our first term and our ratio. If we put in 1, the exponent becomes 0, and anything to the 0 is 1. So we have 24 times 1, so the first term is 24. All right, what's the second term? Well, we're going to put in 2. So we'll get 24 times negative 1/5. Negative 24 fifths. Oops, I'm adding. All right, now I'll put in 3. Now I'll put in 3.
Negative 1/25.
That's going to become positive. So I got 24 25ths. What about you? Can you tell what's happening here? How am I getting from term to term? Every term I just multiply by negative 1/5. So my ratio is negative 1/5. All right, here we go. Let's add them up. The formula says, we're going to infinity using this top sum right here. Formula says we take 24 and divide it by 1 minus the ratio. You said the ratio was negative 1/5. So we have 24 over 6/5. which is 24 times 5, 6, which is 20. Now, if that arithmetic was just completely overwhelming to you, keep in mind you will have a calculator. So if you need to do that on a calculator, you can, but the answer is 20. So the sum of those terms would be 20. Okay? All right, let's look at page, what did I say, 4? Let's look at page 4. It's another old quiz.
Is this one we'll get all these questions?
Yep.
Do I go to my
So let's see if we can figure out what's going on. All right, so read the first question.
Do I go to my secretary and tell her not to do it?
There are some questions, as you read the problem, there are some things you should be asking yourself. What are some things you need to consider before you just start jumping in and doing the problem? Whether it's arithmetic or geometric, so let's decide that. She hits 5 on the first day, 10 on the next day, 20 on the next day. Arithmetic or geometric? Geometric. Okay, so the first thing you got to figure out is, okay, am I arithmetic or geometric? Got it. Now the second thing you have to figure out is, are you looking for just another number in the list, or are you looking for a sum? So let's read the question. How many golf balls will she hit all together? That's sum. So now you know what formula you're using. You told me it's geometric, and you told me it's a sum, right? Now actually, we have 2 of those. So we need to ask one more question. Am I looking for, or which specific sum am I looking for? How many terms am I adding up? In this question, how many terms are we adding up? 9. You did not say infinitely many. You said 9. So therefore, we're using this formula, right? So here we go. S sub 9 equals, let's start plugging. Here we go. What do we have? 5 minus 5 times 2 to the 9 over 1 minus what?
2.
2. Now I'm going to make that -1, not mess with that. And I'll type it in on my calculator. Everything should be fine. 5 minus 5 times 2 to the 9. So I got 2,555 golf balls. Does anybody have a question about that? All right, read number 2 and see if you can answer the same 3 questions. Is it arithmetic or geometric? Am I looking for a term or a sum? Which term or sum? All right, see if you can answer those questions reading number 2. Okay, have you decided whether you have arithmetic or geometric? It is arithmetic, right? Have you decided if you need a term or a sum? It says, how many will he catch in the 14th game of the season? That's a term. So we need the 14th term, right? Formula says 8 plus 3 times 13. What is that, 47? Everybody okay with that? Number 3. Arithmetic or geometric? We got 10, 16, 22. That looks arithmetic, right? You want to add them up, or you want to find a term in the list? How many votes will she have garnered all together? It's going to be a sum. How many terms am I adding up? 90. So according to my formula, this is arithmetic, sum of 90. So according to the formula, it will be 90 over 2 times, oh boy, we have a problem. What goes here, gang? What goes there? The 90th term. And we do not know the 90th term. So guess what we have to figure out?
Solve that for that.
The 90th term. So this is work over to the side. This is not going to answer the question. In order to use this formula right here, you need to know the first term and the 90th term. We do not know the 90th term, so we're going to use that formula to figure it out. The 90th term will be what? 10 plus 6 times 89? So the 90th term is 544. What do I do with the 544? It goes right here. That's the 90th term. So then, did you get 24,930? You okay with that? This formula very often requires you to do that second step because it does. You do need to know the first term and the last term. You have to know them. Number 4, we kind of already practiced. What's your strategy for number 4? What kind of sequence do we have? Arithmetic. So we want to know if 2009 can happen if we take the first term plus the common difference times n minus 1. Can you get 2009 from this formula? That's the question. Can it happen? Well, let's see, if I add 7, does 2016 divide by 3? So 672 equals n minus 1, so n equals 673. What's the answer to the question? It is a term, and it's the 673rd one. Now again, under what circumstances would we say no? If it said, is this a term, what would happen to make us say no? This would not come out even, right? We get some decimal thing. What is the 9th term of a geometric sequence whose first term is 8 and whose second term is -4? We want to know the 9th term. This is easy.
-1/2.
The ratio is -1/2. Can everybody see that?
Well, can you add a negative number?
It's a geometric sequence.
I was just already said that.
You can actually add a negative number, but this is, we're not adding here, we're multiplying. So your 8 times -1/2 to the 8th power. So that's going to be positive. got 1/32, did you? And look at that bonus down there. That's not bonus for us. We know that. What's the answer to that? -3. Very, very good.
Bonus. -3.
Now, let's turn it over and look at page 5.
So neat.
That's all you do is circle it.
Okay, everybody see page 5?
I'm not right. Helping me.
I would love it if could have a volunteer or a pair, a team, to come up and do problem 1, or 5, I guess it's problem 5, and problem 6. I'm looking on page 5. I'm going to leave my formulas here, but do I have somebody who would come up and do which one are you guys doing?
5.
5? Here you go. 5. Is there anybody else? Is there somebody who could come and do 6? Anybody willing to give 6 a try? Thank you. 5.
Steven will do the whole thing.
Here's 6.
Yeah, that's my best.
All right. Now, what should the rest of you be doing?
Working on it.
Working on it.
Please.
I got it. Oh, my mom got me it.
12 days. You add 5.
Oh, we can set up this day. Yeah, on Sunday. Thursday.
I say to her last
So,
why are you talking in third person? Okay, I said to
so there's 7 now. So I think.
That's what I want to do.
I wouldn't even be in my biology class.
For your hair? For your straight hair?
Oh, this, okay, so this equation.
Yeah, then you just
I do not have an email from the parent yet, John. I don't think. I got about a zillion of them. People want to
What? I can't. I'm not doing it. Yeah, I'm not doing that. Oh, so do I. I don't want to get like that. I think it's everyone's going to be like, there's not a mirror, so there's a live for it. Yeah.
And
I guess we could. You're going to get like burns. Yeah, everyone's going to like.
so 6 times.
And if I do not see, then everyone's be like, what is that?
My mom will be from
I mean, I don't, I get it, yeah, I do it, I do my hair, I do, but I don't want you to like,
my dad's
I can just do it. Oh my god. How's she doing it? Dinner? Yes. So great. I love it. It's like, Amber said she had to get her hair done and her dress.
Hey, you know what, Maria? You need to get pencil and paper, okay? Katie Klein, you need to be not worried about hair and nails and dresses and get focused on math.
Hey, why alert?
Being hates you is such a bad. I don't know, I was just very alert now.
Number 6, what's supposed to have a
If I can remember number that generates the sequence.
Oh, okay.
Harry and Cobra.
I could be so bad.
Why do 55 for this?
Because we couldn't.
Okay, let's look at problem number 5
So we have
while the girls are finishing up.
We did
Problem
bad
number
math.
5,
Alert's
notice that we
59.
have an alert. Now, why do we have an alert?
We couldn't find the number. I think we've done it very wrong.
Well, let's look and see. The sequence is 2, 7, 12. So would everybody agree the sequence is arithmetic?
Unless that's 77.
Now the question says, how many M&Ms will he eat altogether on his vacation? That would indicate we need to add these up, right?
It's 57.
So they have determined it is arithmetic and we're gonna add it up. So it's this formula. How many terms are we adding up?
We
12.
made an oopsie there.
We put
Okay.
77 instead of 57, or 50, no, yeah, we put
Okay.
77 instead of 57.
We're adding up 12 terms. Would everybody agree with that? So they said 12 over 2 times the first term plus this would be the 12th term.
It's not though.
That, well, we'll fix it. But the point is, you're right on target. That is an alert because you don't have that number.
How'd you get 55?
Okay.
77.
So over to the side, right here, they said the 12th term, which is what has to go in this blank, the 12th
57.
term is the first term plus the common difference times 11. So I don't know, that should be 57.
Yeah, we got 55, 12 times. It's a
So
whole
5
thing.
times 11 is
Yeah, yeah, yeah.
55, plus 2 is
I don't know what I was
57.
doing.
And then like we pulled a 77 out of nowhere.
I think it's from Rome.
So
I have
that
77.
number should be 57. Then we take 57 plus 2 and times that by 6, and the real correct answer would be 354 M&Ms.
At least we were alert.
You were. And again,
Why were you-
that formula often requires that extra work. Good job.
Why were you alert?
Does anybody have a question about number 5? Okay, now number 6, we have a lot written down here. Let's see.
I went with it.
It says the first term of an arithmetic sequence is 19. The sum of the first 12 terms is 690. Find the 12th term and the common difference. Okay, so where do we even begin? If we know that the sum of an arithmetic sequence is 690, we should probably begin with that formula. Would you agree? So that's what they did. They said the sum is 690. That equals 12 over 2, because that was the sum of 12 terms, times 19, which was the first term, plus the last term, which is the one we're looking for. Right? So what did you do here? You made that a 6, and then you distributed, and you subtracted and divided and got that to be 96. So they said the 12th term was 96, just doing the arithmetic. Here's the equation. That's the starting point. Then they said, okay, the 12th term is 96, the first term is 19. So then they went to that formula. This is kind of small. They said 96, the last term, equals the first term plus the difference times 11. This is beautifully done, girls, beautifully done. Then they solved that equation and got the difference is 7. So this was step 1. They kind of got it upside down here. This is step 1. That came straight from the given. Harry's your hand up.
No, I was a big stretch.
Here's the deal, folks. In this equation, they knew the sum was 690, they knew n was 12, and they knew the first term was 19. So they just solved for that. Once they got that, then they knew this number, and this number, so they solved for okay, we're getting ready to erase these. Does anybody still have a question about one of those problems? Okay. Well, guess what? Let's have a volunteer or team to come up and do 7 and 8.
Hey, Ben, you trying to get back
So
up?
anybody feeling good about 7? This was very nicely done on both parts. Everybody did a good job on these.
You can only learn one way, man.
Where are you back up here? Is there somebody else that wants to do 7?
No one else really. This is a sign crowd.
All right.
Got a lot of dedication. He's for it.
You do.
Love you, Stephen.
You did a good job on the last one, except for your careless mistake.
Okay, I want to call it.
How about 8? Anybody want to do 8? Anyone say about 8? Stephen, good, thank you. You gonna go by yourself? You and Annabelle? Awesome.
Okay, so how much did you spend altogether? Wait.
For 8.
There's a problem. Annabelle. Share in front of the equations. There we go. So, I think. Oh.
Don't we use the same thing we did last time? Oh, no, this is not this.
Yeah.
I'm pretty sure we did this bottom one. This one is if you did. I'm pretty sure we did this one.
Oh, we need to add them all together. So we do this one.
Yeah, I got John
We did the
Preston.
bottom one.
Oh, I got Julie Preston too.
Yeah.
Both of them.
They both came right together. And they both said it was okay.
First term.
So we got double commission.
This one?
Minus 0.2.
Same page.
R is ratio, so it's different or asymmetric.
One minus one.
Yeah, well, R is just ratio, so that's right.
It's right.
That's right.
Okay.
Yeah.
Oh my
It is, I
God.
think it's 3.
Wow.
They're talking about 3.
To the nth power, which is 8.
What is that number?
Minus 1. That's just sum of the nth.
Oh, so we
Tomorrow morning, we're gonna go over all these tests that
It's pretty hard.
Did you spend all together? Oh, 8 consecutive days.
Did you guys have that section?
6,000 divided by. You're very big. Shall we back up a little bit?
No, I did that. I'm not gonna do that, but I said that correct.
Yeah. 6,560.
Should I say alert, like the dollar signs?
Where will we say alert? Oh, alert.
That's why we signed it. How you write alert?
Yeah, I put some money signs next to it. So 45. We're gonna use this. I think we did right.
All right, they're both done. Good job. What are, those of you at your seats,
It's the term, like the 45th.
did you
term.
get $6.56?
Okay.
Does that look right?
Maybe. Probably, yeah.
Okay, we have a little bit of a problem.
No.
Alert again.
That's 65.
Here's the issue that we have. What are the terms of the sequence? They put decimal points in. What should the real first term be? If you're going to put decimal
0.02.
points in,
0.02.
it should be 0.02.
Oh, man.
Now, can you do the problem without putting decimal points in? Absolutely. You can do 2, 6, 18. So if you think it's going to be easier for you not to mess with that right now, that's fine. Here's the series. How much did she spend altogether? We're adding up the sum of 8 terms. So their idea is exactly right. But they got a decimal point issue. Divided by 2. So this comes out to be 6560. Now, I did not put decimals into my problem. So this is 6,560 cents, right? So when I write my answer down, I'm going to write it the way a normal human being would write it, and that is $65.60.
You can't say
Okay.
6,560
Now,
cents.
you guys
That's why I got the alert.
you did
That's what the alert was about.
You did exactly the right thing, but you've got some issues with your decimals. Okay? Does anybody have a question about that?
Throw another one up there. We got it. We'll go 1 to 3.
You don't leave it as 6,560 cents. You write
So
it
you got the
as
alert.
cents.
So if you put 0.02, it's still coming out to 65.06.
Yeah, because it needs enough to
Now,
drop the
if
point.
you put in .02,
The division will be the same.
everything will be exactly the same, only it will actually come out this way. You won't have to put the decimal in there. All right, and then these guys, okay, this is another one. This is the third time it's happened to us today. They read the problem and it said, you got 7 points, then 8, then 9. That's arithmetic. How many will you have accumulated? That would mean sum. And we got 45 days. So they're saying the sum of 45 days. 45 over 2, there's your first term. But what did they need to find? The 45th term. So over to the side or down below, the 45th term is the first term plus the common difference times 44, that's 51. So then they put their 51 into their sum formula and worked it out and got that. Did anybody else get that? So this happens a lot. When you're doing an arithmetic sum, you usually have to use that formula to find that number. You usually don't know that number. You usually have to find it. It's happened to us 3 times today, to just say. Okay? Now, let's look at the limits. It's page 8. Let's look at page 8.
Are we supposed to be memorizing these formulas, or will you give us?
I will give you the formulas. Page 8. Here we go. Let's run down through the limits. We ought to be able to do these in 4 minutes. Here we go. Number 1. We're on page 8.
So,
Oh my gosh.
Burning through this book.
It's 0. It's 0 because the fraction is less than 1. It's bottom heavy, so your limit is 0. What about 2? Divergent. No limit. Divergent. 3.
-7.
Negative 7/5. All right, now wait, number 4, remember you do each part separately and then times them. So 3/4 times 1/2 would be 3/8. Everybody getting 3/8?
So it doesn't make a difference when like one is just n and the other one's n squared?
No, you do each fraction separately.
Cool.
5, divergent. The fraction that you're raising to a power is bigger than 1. It's top heavy, in other words. How about 6? 0. Your biggest power is on the bottom, that makes it 0. What about 7? -6. Good, I tried to be tricky, but I couldn't trick you. Number 8. 0. I don't care about the negative, the absolute value of the fraction is bottom heavy. Number 9. The limit of the first part is 6.
6 minus
The
0.
limit of the second part is 0. So the answer is 6 minus 0 or 6. Number 10.
2/3.
2/3. Wonderful work. Okay, for Monday, this is due Monday. I need you to do, oh my gosh, we've done everything in class, I was gonna have you do, so I'm gonna change that. I would like you to do page 1. Now, page 1 has a front and a back. Page 1, that is due on Monday. Now listen, you guys know about the schedule on Monday, right?
No. Oh wait, don't we get there like 8, 9?
Yeah, you come later, I don't know what time, you figure that out. But we have like 2 periods, I mean, we're like in a block.
Yes!
So, here's what's gonna happen on Monday. We're going to review, we're gonna go over this. I think there might be one more thing in here we haven't done, we'll do for practice. And then, actually stop, I'm gonna change the assignment. Do page 10. Do page 10, front and back. Not page 1, do page 10, front and back. That's last year's quiz or some year's quiz. We're gonna go over that, we're gonna practice, and then at the end of the period on Monday, we're actually gonna take this quiz, okay?